day everyone. So for this video, we will going to discuss the fundamental principle of counting. So the objective of this lesson is you should be able to illustrate and apply the fundamental principle of counting. So to start with, let's have this example number 1, tree diagram. A family has 4 children. Draw a tree diagram to show the possible genders of the children. So in order for us to make a tree diagram, let us first write the possible genders of the children. So when we talk of gender, we are referring to either a boy or a girl. Okay, so let's start with the boy. So if we have a boy, then the first boy or the first child is a boy. For the second child or children, we have boy or a girl, and then for the third, we have either a boy or a girl. This is for the third children, and then this one also we have a boy and a girl. So for the fourth children, we also have a boy and a girl, a boy and a girl, boy, girl, boy and girl. So if we will going to list the possibilities, we have boy, 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 this one. Then we have boy, 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 girl. We also have boy, boy, girl, boy, 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 girl, girl, boy, girl, boy, 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 girl, boy, girl. We have boy, girl, girl, boy, and then we also have boy and 3 girls. So this is the list of possible genders of 4 children. But we must consider also that the first child can be a girl. So this is a girl. Okay. Possibilities that for the second child you also have boy, girl. For the third child you have boy, girl, boy, girl. And then for the fourth child, the boy, girl, boy, girl, boy, girl, and boy, girl. Okay. So if we're going to list again the possible genders, we have girl, boy, 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 girl, boy, boy, girl. Also have girl, boy, girl, boy, girl, boy, girl, girl. We have girl, girl, boy, boy, girl, girl, boy, girl. We also have girl, 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 boy, and then we have 4 girls. Okay, so these are the list of the possible gender using tree diagram. But if we're going to count how many possible genders, so we just simply count the number of possibilities. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Therefore, we have 16 possible genders of the children. Okay. Okay, using the tree diagram. So this shows how you will be able to use tree diagram in order to list down possible genders. Okay, next. So I want you to try this one. A family has 3 children. Draw a tree diagram to show the possible genders of the children. So you can refer to our first example in order for you to do this part. So we have now come with the definition of the fundamental counting or fundamental principle of counting. According to the definition, if one thing can occur in m ways, so one thing m ways, and the second thing can occur in n ways, and the third thing can occur in p ways, and so on, then the sequence of things can occur in m times n times p times so on ways. So this is the fundamental principle of counting. Okay. So let's have example number 2, fundamental principle of counting. The Exponent Ice Cream Parlor offers the following choices on the right for their snacks. Suppose you choose a sandwich and a drink. How many possible outcomes are there? So we have your sandwich. For the sandwich, we have hamburger, chicken, and egg. For the beverage, we have juice and coffee. So if we're going to list the possible outcomes using the tree diagram, we can write hamburger, then we have juice or coffee. We also have chicken, then we have juice and coffee. And we also have egg, then we have juice and coffee. So the list of possible outcomes are hamburger juice, hamburger coffee, chicken juice, chicken coffee. We have the egg juice and egg coffee. So since the question is how many possible outcomes, we just simply count 1, 2, 3, 4, 5, and 6. So therefore, there are 6 possible outcomes. Okay? So, but how about if we were going to apply the fundamental principle of counting? So if you have one thing, can occur in m ways, second thing can occur in n ways, and third thing can occur in p ways, and so on. So we just simply follow this pattern or sequence. We have n times p times so on ways. So for the sandwich, so here we have using fundamental principle of counting. Okay. So for the sandwich, we have 3 possibilities. We have hamburger, chicken, and egg. And for the beverage or the drinks, we have 2. We have the juice and coffee. So one thing can occur in m ways, so this will be your m. And the second thing can occur in n ways. So therefore, in order for us to solve the possibilities or the possible outcomes, just simply multiply it. Okay? So 3 times 2, it gives us 6. Therefore, based from the tree diagram that we just did a while ago, we can conclude that we have the same answer from the tree diagram, and that is 6 possible outcomes. So that's how we use the fundamental principle of counting. So I want you to try this. Acts 12:6, convenience store offers the following choices for their snacks. Suppose you choose a sandwich and a drink. How many possible outcomes are there? So you can try answering this using tree diagram and confirming it using the fundamental principle of counting. So for the definition, we have two events A and B are independent events. When? So when can we say that the events are independent? When the occurrence of event A does not affect the occurrence of event B. So meaning, event A is independent to event B. Okay? So, whereas two events A and B are dependent events, when the occurrence of event A affects the occurrence of event B. Okay, so when we say again independent, the event A does not affect event B. When we say dependent, event A affects the event B. Okay, so let's proceed with the next example. A special plate number is made up of 3 letters of the English alphabet followed by 2 digits. How many plate numbers are possible if A. The letters and digits can be repeated in the same plate number, and for B, the letters and digit cannot be repeated in the same plate number. Okay, so here, okay, so we're going to solve for this problem. Here, okay, first thing that we need to know is the composition of a plate number. So in this problem, it is given that a plate numbers consists of 3 alphabets or letters followed by 2 digit numbers. Okay, so it is not possible that we use the tree diagram here because it will be so tedious, and as we all know, there are 27 letters and 10 digits. So this will be not inappropriate, okay, to use the tree diagram. With this, we will directly use the fundamental principle of counting. Okay, so for the first scenario, the letters and digit can be repeated. Meaning, okay, you can use the same letter or number on the plate number. There's no restriction here. Okay. So let's write the letters, 3 letters. Let's say this will be the 3 letters and the 2 digits. Okay. Since the letters, okay, can be repeated, okay, so how many letters are there in the English alphabet? So that's the first thing that we need to know. How many letters are in the English alphabet? So when we talk of English alphabet, there are 26 letters. Okay, so for the first letter, we can write 26. Why 26? Because any of the letters will do. The possibility is 26 because any one of the 26 letters will do. Okay? How about for the second letter? Since the condition is can be repeated, okay, we also write 26. Okay? Because, let's say for example, on the first letter, the letter is A. Say for example, since the condition is can be repeated, for the second letter, it will also be A. So there's no restriction. Okay? So that's why we also write 26. And same with the third letter. We also write 36. So it's possible that your plate number will be AAA because of the condition. Okay. How about for the digit? When we talk of digit, there are 10 digits. Why 10 digits? Because 0 is included. So if you're going to count from 0 to 9, that gives us 10 digits. So here we just simply write 10. Okay, because any of the 10 letters will do from 0 to 9. It can be 9, it may be 8, or whatsoever number, as long as it's from 0 to 9. Okay, so let's say we have here 2. How about the second digit? Since that can be repeated, we also write 10, because 2 is also a possible digit, since it can be repeated. Therefore, according to the fundamental principle of counting, we simply multiply all of this. to get the possible numbers of plate numbers. Okay. So if we're going to multiply 26 times 26 times 26 times 10 times 10, it gives us, okay, I use calculator here since this is a big or larger number. It gives us 1,757,600 possible plate numbers. Okay, so there are 1,757,600 possible plate numbers if we apply the condition that the letters and digits can be repeated. Okay, so how about for letter B? The letters and digits cannot be repeated. So if we have A on the first letter, obviously A cannot be used on the second and third letter because it cannot be repeated. So therefore, we have 5 here. First is, for the first letter, we have 26. Why 26? Because all of the letters are possible. All of the English alphabet letters are possible. It's from A to Z. Okay? Let's say we choose A. But for the second letter, since it cannot be repeated, so obviously A will be removed from the list. So from 26 possible letters, just be 25. Why 25? Again, because A is already removed. Okay? So let's say for example here we choose B. Okay? How about for the third letter? Okay, you are correct. For the third letter, we have 24. Why? Because A and B cannot be repeated. So we have two letters that cannot be repeated on the third letter. So that will be, if we have 26 letters, just simply remove 2. That gives us 24. So let's say this is C. Okay? So how about for the digits? For the digits, you also have the same. For the first digit, we have 10. Because the possibility is from 0 to 9. Let's say we choose 2. But for the last digit, for the second digit, 2 cannot be repeated. Therefore, from 10 possible number or digit, you only have 9. Let's say this is 3. So again, according to fundamental principle of counting, we just simply multiply this 26 times 25 times 24 times 10 times 9, and it gives us 1,404,000 possible plate numbers. Okay? So for letter A, we consider this as what? The independent event. Why independent events? Because the occurrence of the other is not, or the occurrence of the first letter or first digit, okay, does not affect the occurrence of the second or third letter or digit. So that's why we call it here independent events. But for the letter B, this is what we call the dependent events. Why? Because the existence of the first or the second is dependent on the existence of the first. So, let's say for example, if we choose A for the first event, the second letter will be dependent on the first letter, that is A. Because we cannot repeat what was chosen in letter on the first letter. Okay, so if we compare this, if we compare the two possibilities, we could say that there will be more possible plate numbers if the letters and the digits can be repeated compared to the special plate or the possible plate numbers that cannot be repeated. Okay? So, here, we can apply it in real life situation. How? So, in the Philippine setting, plate number is given by 3 letters and 4 digits. This is for Philippine setting, PH setting. So can you provide the possible plate numbers if the digits the letters and digits can be repeated and cannot be repeated. Okay, so it's up to you. Okay, so we proceed to the next example. Okay, so for the next example, the question is, 5 cards are drawn from a standard deck of cards. So hopefully you know what is a standard deck of cards. Standard deck of cards consists of 52 cards. Okay? 3 are black and 2 are red. So for question letter A, how many possibilities are there? And for letter B, if exactly one of the red cards is a face card, how many possibilities are there? But before we proceed answering this question, so let us take a look. Let's take a look at what is a standard deck of cards. Okay? When we talk of standard deck of cards, actually we have 4 characters or icons here. We have the heart, we have the diamond, we have the spade, and the club. Okay, so you know what is heart. You know what heart looks like. You know the diamond. Okay. You know the spade. Okay. Looks like this. And you also have the club. So that's how it looks like. Okay. So when you talk of heart and diamond, these are considered red cards with 13 cards each. So what are the 13 cards? The 13 cards are ace, 2 to 9, 2 to 10. Then we have the face cards which are jack, queen, and king. By the way, joker is not included. Okay? So for the spade and club, these are the black cards. It consists of 13 cards each. Okay? So 13 times 4, that gives us 52. Okay? So that's the composition of a standard deck of cards. So we now go back to the question. Okay? So, by the way, if we have 3 face cards, we say face cards, that's the jack, queen, and the king. Okay? So, since we have 3 face cards and we have 4 icons, heart, diamond, spade, and club, so we have 12 face cards. So there will be 12 face cards. Okay? So let's try to answer the question. 3 are black and 2 are red. Okay? So here, we have a situation that 3 are black, okay, 2 are red. So for letter A, if you have the black and you have the red, okay. So 3, okay. So 3 are black and 2 are red. Okay. So how many possibilities are there? So when we talk of black cards, that consists of spade and club, and we have 13 cards each for each icon. Therefore, we have how many? We have 26. Right? Okay, why 26? Because spade has 13 cards and club card has 13 cards also. So 13 plus 13 is 26. For the next card, since the first card was already chosen, obviously you cannot choose again the same card. So for this case, we also have 25. So just simply remove one card. Okay? And for the third card, we have 24. Okay? How about for the red cards? For the red cards, we You also have 26 because heart has 13 and diamond also has 13. So 13 plus 13, 26. So 26 red. And for the next possibility, we have 25. Since the first drawn card cannot be drawn again. Okay, so according to fundamental principle of counting, we just simply multiply all of this. Okay, if multiplying 26 times 25 times 24 times 26 times 25, it will give us a product of, okay, 10,140,000 possible outcomes. So as you can see, okay, so there are many possibilities. Choosing 3 black cards and 2 red cards. Okay? How about for letter B? If exactly one of the red cards is a face card, okay, so one of the red card is a face card, so how many possibilities are there? So, using the same logic, we have the black and the red card. So for the black, we have 3. For the red, we have 2. But, there is a condition that exactly one of the red cards, okay, okay, so exactly one of the red cards. Okay, so here for the black card, you just simply follow the sequence. You have 26, 25, 24. But how about for the red card? It says here, if exactly one of the red cards is a face card, okay, red card, so we are pertaining to red cards. Exactly one. So how many face cards are there when we talk of red cards? For the heart and diamond. So you have Jack, Queen, King for the heart and Jack, Queen, King for the diamond. Therefore, we only have 6. Correct. 6 face cards. Okay? So, since we have the exactly one face card, okay, for the next card, for the next red card, we only have 20. Okay? Because from the 26 total red cards, we remove the face cards and there's 6 face cards. Okay? So, according to the fundamental principle of counting, we just simply multiply and gives us 1,872,000 possible outcomes. Okay? If exactly one of the red cards is a face card. Okay? So, see the difference? Okay? So, yes, that's it for example number 4. So, for try it number 3, solve this. 5 cards are drawn from a standard deck of cards. 2 are face cards and the rest are number cards. How many possibilities are there? Okay, so try to answer the try it part. Then if you have any questions, we can discuss that on the next synchronous class. Okay? So, that's it for the fundamental principle of counting. Bye!